So now that you have a good understanding of what generics are, let's see how they work under the hood. So I've removed the constraint on this type parameter. We only have t. Now let's recompile our code. So on the top, from the build menu, let's go to build project. Next, we open the project window, select the generic list class, and from the view menu, we go to show bytecode. Here you can see the actual bytecode that is generated as a result of compiling our Java code. Remember bytecode? We talked about it in the first part of this series. Bytecode is a platform-independent representation of our Java code. So when we compile our Java code, the Java compiler will produce this bytecode that can run on different platforms, like Windows, Mac, and Linux. Now, when we run our program, the Java virtual machine will get this bytecode and convert it to the native code for the target platform. So if you run this code on Windows, we have an implementation of Java virtual machine that knows how to convert this bytecode into native code for Windows. We also have an implementation of Java virtual machine for Mac, for Linux, and other operating systems. Now, why do we care about this? Well, if you scroll up, you can see different pieces of the generic list class. For example, over here, we have our two private fields. Here we have the items field and the count field. Now look at the type of the items field. It's an object. Well, more accurately, it's an object array. Also, if you scroll down, you can see our add method. Now look at the type of the parameter of this method. It's the object class. So when we compile this code, the Java compiler will replace all these t's with the object class. And that means internally, this class is implemented like the non-generic list that we created earlier. This class over here. So when we compile our code, our generic list will end up looking like this in bytecode. The difference between these two implementations is compile time, type safety. So when we use the generic implementation, the Java compiler will check for type errors at compile time. But internally, our integers, our strings, our user objects are stored in an array of objects. And this is not because we have set this field to a new object array. Even if we don't do this, the Java compiler will still replace all these t's with the object class. Now let's see what happens when we apply a constraint. So here I'm going to type extends number. Now we recompile our code. Then from the project window, we select generic list and go to show bytecode. Take a look. Now the type of this field is number. Similarly, if you look at the add method, the type of the parameter is changed to number. So when we apply a constraint, the Java compiler will replace all these t's based on the constraint that we have set here. Here our constraint is the number class, so all these t's will be replaced with the number class. If you have an interface, let's say comparable, all these t's will be replaced with the comparable interface. Now what if we have two constraints, like comparable and clonable? Let's take a look. So we recompile the code, then look at the bytecode. Take a look. The type of the items field is comparable. And similarly, the type of the parameter of the add method is comparable. So when we have multiple interface constraints, the Java compiler will take the leftmost one and use that to replace all these t's. This is called type erasure, which means the Java compiler erases these type parameters and replaces them with a class or an interface depending on the constraints. If there are no constraints, all these t's are replaced with the object class. So this is how generics work under the hood.